This is video 4 on section 4.2, and in this section we are going to graph rational functions. There is a document on Moodle that gives all the steps for graphing rational functions that may be helpful for you. I will work through a few examples here on the screen. This first function that we have is f of x equals x minus 1 over x squared minus 4. The first thing that we need to do is we need to factor the numerator and denominator completely. The numerator does not require any factoring. The denominator factors into x plus 2 times x minus 2. Once we have factored the numerator and denominator completely, we determine the domain. The domain is, as you will recall, the values that make the denominator equal to 0, and we need to exclude those from the domain. So in this particular problem, x cannot equal negative 2, and x cannot equal 2. The second thing we need to do is determine the vertical asymptote, or asymptotes. The vertical asymptotes, once the function is factored and all common factors are crossed out, are the values that make the denominator equal to 0. So in this case, x equals 2 and x equals negative 2 are our vertical asymptotes. We can begin our graph by placing 2, x equal 2, and x equal negative 2 as vertical asymptotes. The next step is we need to determine the horizontal or oblique asymptotes. And we learned that in the last video. We look at the degree of the numerator and the degree of the denominator, and we see that the degree of the numerator is less than the degree of the denominator. Therefore, we have a horizontal asymptote, and the equation would be y equals 0. So I'm going to go back to my graph, and I'm going to graph the asymptote y equals 0. The next thing we need to determine is our x-intercept or intercepts. And in order to find the x-intercepts, you let the numerator equal 0. So if I set my numerator equal to 0 and solve, I get x equal 1. That is my x-intercept. I'll go back to my graph and I will put the point 1, 0 on the graph. Now I need to find the y-intercept. Now this is a function, so there will only be one. And in order to find the y-intercept, I need to let x equal 0 in my original function. If I look at the original function and I put a 0 in for x in the numerator and 0 in for x in the denominator, I get y equals negative 1 over negative 4, which simplifies to a positive 1/4. I'll go back to my graph and I will put a point at positive 1/4. The last step, after we have determined the vertical asymptotes, the horizontal or oblique asymptotes, the x and the y asymptotes, is to look at your graph. And we need to look at the three areas that our asymptotes have divided our graph up into. We've got the area to the left of -2. We've got the area in here between -2 and 2, and the area between 2 and infinity. So what I need to do is just use my calculator and choose some numbers in each of those areas so that we can determine what some good points would be to graph on the graph. So you can use any numbers that you would like. I am choosing -4, -3, -1, 3, and 4. You plug those numbers into your calculator, into the original function, making sure that when you plug them in, you use parentheses in the numerator and the denominator. So for this first one, if I put a -4 in for x, I get -5 in the numerator, and -4 squared is 16 minus 4 is 12, which is -5/12 in the denominator. Now you will go through and you will find all of the points, and then you'll plot your graph accordingly. And so when I do that, I notice that my graph looks basically like that. Now, one thing that you'll notice is that our graph approaches the vertical asymptotes but never crosses it. A graph can sometimes cross a horizontal asymptote, as you can see right here when we had the point 1, 0.